So for this problem, we're going to factor, solve, and graph this equation and include the halfway points between the zeros to give our graph a little more, a more exact shape. So the first thing we do is we need to factor out a GCF if there is one. It looks like 2x squared can divide out of each term, which is going to leave us with an x squared minus 4. All right, now we'll check for a difference of squares, which this is a difference of two perfect squares. So this can split into two conjugates, x plus 2 and x minus 2. So neither of these are difference of squares now, our new factors. So this would be the factored form. So now when we solve, we're going to set each x factor equal to 0. Keep in mind an x squared is an x times x. So when we say x equals 0 for these, we really have two of them. They count as two solutions, and that's going to affect our graph because of the multiplicity. The second factor, we get x equals negative 2, and the third factor, we get x equals 2. So we have 4 real solutions. 2 of them happen to both be 0, and that's okay. So now when we plot those, I'm going to put the 0. I'm going to put a little 2 to remind us that I had 2 of those. Negative 2 and positive 2. All right, so now we can plug in the halfway points to know a better idea of how high and low we go. So we'll figure out what f of 1 and f of negative 1 equal to have a good idea of the heights. So f of 1 would be 2 times 1 to the 4th minus 8 times 1 squared. And that equals negative 6. We do the same thing for f of negative 1. We'll plug negative 1 in, and we end up with negative 6 as well. So if we plot those, 1, negative 6, 2, negative 6, sorry, negative 1, negative 6. Okay, now let's look at our end behavior, and then we can connect our dots. So leading term determines end behavior. It is to the 4th power, so the end behavior is going to be like a quadratic. All even degrees act the same. So it's like a quadratic, and it's like a positively moving quadratic. So the end behavior is going to be up on both sides, like a positive quadratic. So I'm going to put my 2 arrows like that. I'm going to start on the left, connect through my dots, and hopefully everything will join nicely. So I only had 1, negative 2, so I crossed through there. Since I have 2 zeros, an even number means we bounce. And then I only had 1, 2, so I crossed through there. So since all the points connected and they connected with the end behavior, that's usually a good sign that you use the right multiplicity as you graphed. So this would be the complete graph.